Hi, so I'm going to show you how to use the calculator to help us find some normal distribution type of stuff. So to do the normal distributions, it's just like the binomial distribution. It's in the distributions menu. Oop, right, so you want to hit, my bad, second vars, which is distributions. And then notice the first thing's normal PDF. You will never use that. That's telling you like the height of the curve. Just don't worry about that. You won't need that. Okay, so you do normal CDF, and then you type in, right? Let's say I'm looking at this one on the top left right here. I want to find the probability that a z-score is between negative 1.23 and 0.56. So I want to find that probability, which is the same area. So I simply type in the lower bound, comma, the upper bound. What did I do? Oh, I put a decimal point there instead of a comma. There you go. And then I find out, okay, that area there is a little about 0.89 or 89%. Okay, now there isn't a way to directly, let's look at the picture right below it, right? So in this case, I want to find the area that's just to the left of this particular number. Now, you have to choose a lower bound, so how do we handle that? Well, again, second distribution, CDF. Well, just choose some largish number, right? So we know that like most of our data was in 2 standard deviations of the mean, so basically all of it's within 23. So I'm just going to choose a large negative number, right? Anything larger than 10 is fine. So just put in some random large number and then put in the z-score. Right, so that's about 90%. That's to the left of this line in the second picture, right? And then just to notice, it didn't really matter how negative that number was, right? So let's make it 523. See, it's the exact same, right? Because nothing's 23 standard deviations to the left, nothing's 523. Just choose a number that's maybe, say, larger than 10. That would be fine. Okay. Now, finally, in this case, I know the area underneath the curve. So this is like using that table. I know the area. I have the number inside the table, and I want to find the z-score that cuts it off. Right? So I want to find out what is the z-score that separates, right? This is actually Q3, right? It separates the lower 3/4 from the upper 1/4. So to do that, it's very similar. Since it's an inverse process, I'm going to do second distribution, and now notice it says inv norm. That's inverse normal. And then just type the area underneath the curve, 0.75. Boom. So a z-score of 6.7 will cut off the bottom 75% from the top 25%. All right. So that's it for this calculator video.